Hello students, I hope you all are fine and healthy. We are reading chapter number 3, Atoms and Molecules. Today we will learn the last topic of this chapter, that is mole concept. So first of all, let us understand what is mole. Mole is basically a specific number. It is used for counting the number of atoms or molecules. So mole is a fixed number which is used for counting the number of atoms or molecules. Like in our everyday life, we use different units for measurements or for counting. Similarly, the mole is also used for counting. Like if we say 1 dozen means 12 articles. Like if we say 1 dozen pencil, then it means there are 12 pencils. Now 1 mole of a substance, that substance can be atoms, molecule or ions. It means there are 6.022 into 10 to the power 23 particles of that substance. If we are talking about 1 mole atoms, then it means there are 6.022 into 10 to the power 23 atoms. And if we say 1 mole molecules, then it means 6.022 into 10 to the power 23 molecules. Similarly for ions also. So basically 1 mole is this number. So this number 6.022 into 10 to the power 23, which represents a mole. It is known as Avogadro number. This number is known as Avogadro number on the name of the scientist who discovered it. If I say 1 mole of pencil, then it means 6.022 into 10 to the power 23 pencils, means these many large number of pencils are there. So similarly, if I say 1 mole of carbon atoms, so it means that there are 6.022 into 10 to the power 23 atoms of carbon element. And if we are talking about 1 mole of H2O, then it means there are 6.022 into 10 to the power 23 molecules of H2O. We know that H2O is a molecule. It is a molecule of water. So there are these many molecules of H2O. You might have seen that the people who work in the bank, they don't count the coins because there are large number of coins in the bank. So if they will keep on counting them, so it will waste a lot of time. So instead of counting the coins, they weigh the coin. Similarly, the scientists also count the atoms and molecules by weighing them. They take their weight and they count the number of atoms and molecules from the weight. From the experiments, it has been found that if we will weigh an element equal to its atomic mass in grams, this atomic mass in grams is known as gram atomic mass, then it will have 6.022 into 10 to the power 23 atoms, or we can say it will have 1 mole atoms. Similarly, if we will weigh a compound equal to its molecular mass in grams, this molecular mass that is expressed in grams, it is known as gram molecular mass. Then it contains 6.022 into 10 to the power 23 molecules of that compound, or we can say it contains 1 mole molecules of that compound. We know that the atomic mass of hydrogen is 1U. So its atomic mass in gram, or we can say the gram atomic mass, it will be equal to 1 gram. Whenever we write the gram atomic mass of any substance, then we remove this U and in place of this U we write G, that is for gram. So if we will take 1 gram of hydrogen for an experiment, then it means that we have taken 6.022 into 10 to the power 23 atoms of hydrogen, or we can say that we have taken 1 mole of hydrogen atoms. Now the molecular mass of water is equal to 18U. We have already learned that how to find the molecular mass. So its molecular mass is 18U, and if we will convert it into gram molecular mass or molecular mass in gram, then it will be equal to 18 gram. So if we will take 18 gram of water in an experiment, then it means that we have taken 6.022 into 10 to the power 23 molecules of water, or we can say that we have taken 1 mole of water molecules. The mole represents a definite number of particles of a substance. Along with that, it also represents a definite amount, or we can say a fixed mass of a substance. Now the 1 mole of atom of an element, it is having a mass equal to the gram atomic mass of the element. Like for example, we know that the oxygen is having an atomic mass of 16U. So if we will convert it into gram, that will be gram atomic mass, it will be equal to 16 gram. So now here we have read that the 1 mole of atom of an element, it will have a mass equal to gram atomic mass of the element. So it means the weight of 1 mole of oxygen atoms is equal to 16 gram. Similarly, the atomic mass of carbon is 12U. So its gram atomic mass will be equal to 12 gram. So 1 mole of carbon atom, it will have a weight of 12 gram. Now the symbol of an element, it represents 1 mole of atom of that element. Suppose if somewhere it is written the symbol of carbon, that is C, it means that it represents 1 mole of carbon atom. Similar to the 1 mole of atom of an element, 1 mole molecules of a substance, they are having a weight equal to the gram molecular mass of the substance. The nitrogen molecule, it is represented as N2, and it is having a molecular mass equal to 28U. So its gram molecular mass will be equal to 28 grams. So 1 mole of nitrogen molecules, it is having a weight equal to 28 gram. The molecular formula of a substance, it represents 1 mole of molecules of that substance. Like for example, O2, F2, Cl2, H2O, CO2. They all are the molecular formula of that substance. Now if we talk about O2, then it represents 1 mole molecules of oxygen. Now F2 represents 1 mole molecules of fluorine, and this H2O represents 1 mole molecules of water, or we can say H2O. Then CO2 represents 1 mole molecules of carbon dioxide. Now we will solve some questions based on the mole concept. So our first question is, what is the mass of 4 moles of aluminium atoms? And in the question it is given that atomic mass of aluminium is 27U. So first of all, we will find the mass of 1 mole of aluminium atom. We know that 1 mole of any substance is having a mass equal to its gram atomic mass. So, for knowing the mass of 1 mole aluminium atoms, we will convert this atomic mass into gram atomic mass. So for converting it into gram atomic mass, what we will do? We will replace this U with G. So 1 mole of aluminium atom will have a mass equal to 27 gram. So now we can multiply this 1 mole with 4 to get the mass of 4 moles. So 4 moles of aluminium will have a mass equal to 27 multiplied with 4. 4 sevens are 28, carry 2, 4 twos are 8, plus 2, 10. So 4 moles of aluminium atoms, they will have a mass equal to 108 gram. Now our second question is, 1 mole of carbon atom weighs 12 grams. What is mass in grams of 1 atom of carbon? So the mass of 1 mole of carbon atom is given, that is 12 gram, and we have to find the weight of 1 atom of carbon in grams. So we know that 1 mole of any substance, it is having how many particles? 6.022 into 10 to the power 23 particles. So here it is given 1 mole of carbon atoms. So 1 mole of carbon atoms means 6.022 into 10 to the power 23 atoms of carbon. Now the mass of 1 mole of carbon atom is also given. So the mass of 1 mole of carbon atom is equal to 12 grams. So from here we can conclude that the mass of 6.022 into 10 to the power 23 atoms of carbon, it is equal to 12 grams, because 1 mole is having 6.022 into 10 to the power 23 atoms. Okay. Now 6.022 into 10 to the power 23 atoms of carbon is having a weight of 12 grams. So now we can easily find the weight of 1 carbon atom. We will divide this 12 from this number. So 1 atom of carbon will have a weight equal to 12 gram divided by 6.022 into 10 to the power 23. Now when we will divide 12 from 6.022, we will get 1.99, and this 10 to the power 23, when it will be taken up, the sign of the power will be inverse, means it will be 10 to the power minus 23 grams. So the mass of 1 carbon atom will be equal to 1.99 into 10 to the power minus 23 gram. So that's it, students. Now our chapter is over. Thanks for watching. Bye bye. Take care.